Okay. What is this section? 4? Section 4? All right. The verbal phrase is 4 less than the quantity 6 times a number. Now we have 3 things in here. And we're really talking about less than not being subtraction necessarily. It could be a greater than or equal than sign. We're going to introduce inequalities in this. So the first one, make sure that when we talk about verbal phrases, we understand that in an expression, we say less than, we're talking about minus signs. In an equation, less than is going to be your inequality sign. Got it? Because inequality sign means we're talking about 2 sides of something. All right. So that was 6n minus 4. That's to help you get through this. 6 times the number n. 6n. Less than, remember, we changed the order. This comes before the 4. Okay, does that jog your memory? Okay, let's go on. B. 3 times the sum of 7 and a number. Why? Okay, so now we're still talking about expressions. If you know how to do this, you don't necessarily need to write it down. 3 times the number is what? 3 times the number y? How would you say this? How would you write it down? 7.
3 times 7 y.
What about the sum? Did you happen to say that? I missed it. What's sum mean? Addition. How about 3 times? And since we're needing to add 2 things together before we do the multiplication, what else do we need? Parentheses. 3 times the sum of 2 things. It's not 3 times 7 plus a number y. It's 3 times that addition. That's why it's necessary to have the parentheses. Got it? All right. Why are we doing this? Why are we going through this? Doesn't it seem kind of silly? Anybody understand the point of doing this right now? Story problems. So when you're reading your story problems, you catch on to certain words that are in there. All right, C. The difference of 22 and the square of a number m. Everybody got it? Not giving much back for dredging.
22 minus n squared.
Yes. That was really good. All right. Glad you're paying attention. All right. Translate the phrase the quotient when the quantity 10 plus a number x. Quantity means what again? Grouping. Parentheses. The quantity 10 plus a number x is divided by 2 into an expression. What do you think? Noah.
In parentheses 10 plus x, it's parentheses 10 plus x parentheses divided by 2.
Yeah.
2 over
Now,
fraction bar.
if you write it as a fraction, you won't need the parentheses because the fraction bar is your grouping symbol. But when you first read the problem, you don't know you're going to be dividing until you get to the end, right? But that's right. There's nothing wrong. You can totally put the parentheses in there. That'd be fine. All right. That's the end of example 1. We good? Okay. Example 2. Maybe. Maybe not. A piece of ribbon L feet long. You don't know how long it is. L feet long is cut from a ribbon 8 feet long. The total ribbon is 8 feet long. It's cutting a certain length, L, out of it, okay? Write an expression for the length in feet of the remaining piece. Benji.
8 minus L.
Draw a diagram and use a specific case to help you write the expression. Suppose the piece is cut 2 feet long. Here it's just saying, let's actually use some numbers instead of the variable to get an understanding of it. Like I said yesterday, if you can plug some numbers in, it might help you understand where to put the variable, okay? Suppose the piece cut is L feet long. There's a picture diagram. So here we're talking about, maybe you should draw a diagram that'll help you figure it out. It's 8 feet long. You cut this piece. That's 2 feet. How would you find out what's left? You take 8 minus 2. Min was right. 8 minus L is what you would say. So here's the example with the actual number in it. Here's an example with a variable. Any questions? Okay. Now, if they ask you to draw a diagram, then draw a diagram. If they don't, then just answer the question. So the point of example 2 is to get you to understand different ways of coming up with things. The expression 8 minus L represents the length and feet of the remaining piece. Any questions? Example 3. Again, verbal model for an expression. Here are the tips. You work with 5 other people at an ice cream stand. Not a bad job. All the workers put their tips into a jar. That doesn't sound like fun. No way. That's a terrible thing. You have to share your hard work with everybody else. They share it equally. Write an expression for each person's share in dollars of the tips. What would you say? How would you figure it out? Do you know how many tips you get? Listen to this. I will say this throughout the year. What you don't know is your variable. What don't you know? Tips. Let's just say it's T. I don't know what they're going to say here in a second. And then what would you do? Cameron.
You write an expression of 5 over X for people over how many tips you got.
Well, let me ask you something. We'll use the last example. Let's say you got $100 in tips between all 5 of you. How would you figure out how much goes out to each of you, Cameron?
You take 5 over 100.
You take 5 divided by 100?
Yep.
What's that? Okay, we're going to give your share to be 5 over 100. Tell me what that is on your calculator.
The answer is
Yeah.
20.
5 divided by 100?
Oh, backwards.
Oh, gee, that's like 0.75.
You're going to get 5 cents. We're going to divide up everything else. I want to work with Cameron. What? You want to change your answer?
Yeah, 55 cents. Yeah.
Take 100 and divide it by 5. In this case, what would you say for the expression?
I was gonna say, should it be 6 people because it says you work with 5 others.
Oh, okay, 6 people. Thank you. Very nice. Very nice.
Yeah.
All right, very good. Thank you. The amount that's in the jar is first, and then by the number of people. All right. We're not worried about this. There it is, 8 divided by 6. Here's the answer. Any questions? Thank you, Noah. Very observant. You told him? And you're just going to let him get away with that?
Why don't you tell him?
I can tell.
All right, let's go on to example 4, shall we? Not do this part. Why is that even like that?
Yes, you know.
Car travels 120 miles in 2 hours. Find the unit rate. It did it for you. But notice how many they had to come up with. It took 1, 2, 3, 4 conversions to get it to it. And we just did this on the board, so I'm not going to go through it. Okay? I don't know why. Again, this is a learning curve with this new program. Why is that not working? I know it. Come on. There's example 5. Let's just walk through it. I'm sorry. Yeah.
This is the lesson.
Huh?
What is going on here?
Wait, what?
Lesson 4 is the same thing. Sorry. It doesn't say that on there. Lesson 4 is the same thing, except we're dealing with equations. So let's do a couple examples with equations. It's the same stuff, guys. Relax, hold on. Like I said, this will be a learning curve until we get
Oh, I see. I see.
make sure it's working here. We got plenty of time.
Wait, so we have algebra class here. We have like regular class again.
After lunch.
Okay.
So we have
I'll
2
check
math
the-
classes.
Equations and inequalities. Here we go. Can you do this? It's exactly the same stuff we've been doing, except now we start introducing the equation versus the expression. So the difference, again, of twice a number, k, and 8 is. Is means what? All right, so there's not a problem here. If you needed to write that, you notice there's an example of it. All right, I'm going to go on to another example. How do you solve it? You're only writing the equation at this point.
Can't really solve it.
Okay? There's an inequality example for you. The product means multiplication, right? 6 in a number and is at least. And you may want to add this to your
Yeah.
notes from yesterday. At least is greater than and equal to. Greater than or equal. At least means that. So yesterday's notes, you may want to add that to our phrase list. At most is what? Less than or equal to. At most. At most. It can't be greater than that, right? You're at most 15.
Oh.
14, right? 13. Oh, man. I was still correct, though. I said at most 15. We've had some 16-year-olds in here. Nice. We have. A number y is no less than. What's no less than? Or equal to.
Oh, that's true.
And no more than. There it is. So there's a combination inequality.
I will be the first class.
All right. Now this is where we're actually going to do some substitutions. Check whether 3 is a solution of the equation or inequality. All right? So here's the equation. What are you going to do? Okay, substitute the number 3 in for x. What are you going to do first? 8 minus 2?
No.
Okay. Good. Yeah, it is a solution. So you're going to have a group of problems like that where you have to check it. All right? All right, so let me give you your assignment. And then we'll work on it during algebra class, okay?
No.